Okay, so number 13 is the hardest one yet. So it says, let f be a function defined for all real numbers x. If f prime of x equals this thing here, then f is decreasing on the interval. Okay, maybe it isn't as hard. Let me think. All right. So this is the derivative. Okay. So we are looking for the interval on which the function is decreasing. Oh, actually, this isn't that bad. All right. So we want the interval, think about it. For f to be decreasing, the derivative needs to be negative. So this question boils down to, when is this thing right here negative? Well, let's think about it. The numerator is an absolute value, which means the numerator is always positive. Well, if the numerator is always positive, then the entire thing is going to be negative only when the denominator is negative. So we are looking to make x minus 2 less than 0. So add 2 to both sides, or just think about it. And x has to be less than 2. That means that the derivative will be negative when x is less than 2. So the original function will be decreasing on the interval from negative infinity to 2. And it's a. All right, that wasn't as bad as I thought. All right, so 14. 14 says this. Let f be a differentiable function such that f of 3 is 2 and f prime of 3 is 5. If the tangent line to the graph of f at x equals 3 is used to find an approximation to a 0 of f, that approximation is. All right, so let's think about what this is asking. All right. It says we have f, it's a function. All right. We know f of 3 is 2. I'm going to go ahead and I'm going to mark that. F of 3 is 2. Okay. So whatever the function looks like, that point exists. Okay. We are trying to find an approximation to a 0 of the function. So we want to know, when does the function, whatever it looks like, hit the x-axis? Okay. That's what we're after. Well, they tell us that f prime of 3 is 5. That means the slope of the tangent line at x equals 3 is 5. So I don't know much about the function, but I do know for a fact that the slope of the tangent line is 5 here. Okay. Now it says if the tangent line of the to the graph of f at x equals 3 is used to find an approximation, what is the approximation? So they're saying literally use that tangent line right there and use it to approximate the 0. So the question boils down to, and I'm not sure whether I've made this clear enough, where does this tangent line hit the x-axis, right? So maybe the function looks like that or something, and we are using this tangent line to be like, well, it's about there, okay? So what do we know about this tangent line? Well, we know its slope is 5, right? Its slope is 5, that's a fact. And we know it goes through the point 3, 2. And we want to know, where does it hit the x-axis? There are a few different ways to do it. But if you like, you could even write an equation for the line. You could be like, well, y minus 2 equals 5 times x minus 3. And we are looking, right, for where it hits the x-axis. That's when y is 0. So we want to know when y is 0. So we get 0 minus, let me move this up. 0 minus 2 equals 5x minus 15. I distributed the 5. So I'm going to add 2 to both sides. I'm going to get 0 equals 5x minus 13. The rest is algebra. Add 13 to both sides. 13 equals 5x divided both sides by 5. X equals 13 over 5, which is 2.6. And sure enough, there it is, C. And like, it makes sense, right? So it hits at 2.6. That's what that is. That might have been a confusing explanation. All right, let's look at the last one here. It says, the graph of the function f is shown in the figure above. Which of the following statements about it is true? Okay. I'm just going to go through them one by one. So let's look. Is the limit as x goes to a the same as the limit as x goes to b? Well, the limit as x goes to a is pretty clearly 2. Remember, the function doesn't need to exist for there to be a limit. It's 2. The limit as x goes to b, so as we kind of come in from both sides, well, it doesn't exist because it doesn't match. So it's definitely not a. There is no limit as x goes to b. Okay, let's look at b. It says the limit as x goes to a of the function is 2. Yeah, true statement. Let's just quickly see why the other ones aren't true. It's got to be b, though. So c is limit as x goes to b is f of fx is 2. So as x goes to b, no, these things don't both go to 2. From the left, it goes to 2. From the right, it doesn't. Okay, so it's not c. D, limit as x goes to b is 1. No, certainly not. We know there is no limit because the right and left don't match. And then this is the one you're going to be tempted to say is correct, that the limit as x goes to a of the function doesn't exist. You're going to look at it and you're going to be like, well, look, the function doesn't exist. Again, it doesn't matter. It doesn't matter whether the function exists. It matters as we get closer and closer. Does the limit exist? And yes, that is true, even though there's a hole there. So it's B, and that's that.